morning, students. Welcome to the LabVIEW programming tutorial. In today's session, we'll enter into experiment number 3, that is sum of n numbers using for loop. Sum of first n numbers using for loop. Okay, so we'll going to concentrate on this VI today. Okay, yeah, so sum of first n numbers using for loop. So what is the basic logic in order to identify the sum of first n numbers? Say for example, first 10 numbers, what do you need to do logically? Of course, you need to call the first number, it starts from 0, so increment that to 1 and add with 0 plus 1, then store the result, then pass on that result to the shift register to add to the next iteration, right? Then similarly you continue till you reach the final count that you require. Okay, so let us directly jump into LabVIEW tool. Okay, I launch the tool. Simply just close the existing projects. I'll go to File, New VI, say Control T in order to view VI, the front panel and block diagram simultaneously. Now we are doing experiment 3 VI, right? Experiment 3 VI to find the sum of first n numbers. Sum of first n numbers, right? So now, as I said, what will be the n? That's your given number. Say I want first 10 integers, sum of first 10 integers, then given number is 10. Okay, so now let me take a control for that. Okay, let me take it as given number that indicates the n, correct? That indicates the n. Okay, now then what else you need? In order to show the sum of that, you need a indicator, that's it. So numeric indicator, this shows the sum of n integers, sum of n integers. Okay, now let us build the logic for this. So as I explained the logic, what is the primary logic that we need to use? We need to iterate this till we reach the count first. So if you want to do the similar operation for many times, then we need a loop. Okay, so here we have in the block diagram, if you go to right click and take the structures, all the possible loops are being presented here. Okay, so now we'll take up for loop. So what I am taking, it is a for loop. How this for loop works, which will, if you don't know anything about the logical function that you take, what I said you to go through. So this is help of the tool, right? Help of the tool. You can just you can see the outline of the function. So that the for loop will do execute its sub diagram n times, where n is the value wired to the count terminal called as n, and I shows the iteration terminal, and the loop iteration count which ranges from 0 to n minus 1. If I say n is 10 now, so 0 to n minus 1, so 9 iterations will be happened. Okay, 0 to 9, that counts the 10 iterations, but the iteration value starts from 0. Okay, so this is how the for loop works. What is this? I'm taking it as a for loop. Okay, let me label that for loop this side. Okay, so now I'll connect my given number n to the n terminal, which indicates where you want to stop the execution. Okay, now what I'll do, as I said, I need to add these two numbers first. We start with 0. 0 plus 1 need to be added. So this iteration can be incremented to 1 and then we can add to the with the 0, right? So now I'll go to numeric, I'll take add and I'll place inside. And what is this logic about? It's a add function. Okay, I'll increment this I value or iteration value by incrementing by one time. Okay, so I'll call increment. I'll just say label of it. This is the increment. I'll connect this I and I'll connect this incremented output to the adder, and I should add with 0 first, right? So in order to give the 0, I'll go to numeric constant and I'll connect 0 directly to the adder. Okay, then I'll pass this result to the output of the loop. Okay, so this, if you do this now, it will only execute one time, right? Now after adding 0 with 1, the 1 should be stored here and the 1 result should be fed back to this loop again, right? So you need to make use of the shift register. So right click and replace with shift register, or you can also have add shift register here. Okay, since I have already been connected with the tunnel, you can, otherwise you can delete this line. Okay, and you can call the shift register, add shift register, and you can call the result of add. Okay, then you can also delete this line and you can connect that into shift register output properly. Okay, so you can go with wiring and then connect. Why it is 0? Because you want to add the result with 0 at the initial stage. Okay, so addition will be initialized with 0. Okay, identity element of addition is 0. That's why I am making use of 0 for the initialization. So look at here now. So now it is ready. Where the output will be stored at this, after the n-1 iteration, you can then look at here. Yeah. So this is what the logic to build the VI for sum of n numbers, to find the sum of n numbers. So let us understand step by step now. Okay, so in order to weave the step by step operation, we can make use of the wait millisecond delay, as we done in the as we know how to do it in the conventional languages. Like we need to wait for some time delay, right? We use the variable and let it calculate for till 1000, so it will wait for 1 millisecond. Okay, so similarly we have timing operations here. I'll call wait milliseconds. So I'll connect the input with the constant, create a constant for this, and I'll just enter 1000, which shows 1 second for each iteration. Okay, so now I'll put that into run mode. Okay, before that, let me give input as 10. Okay, the first 10 integers to be added and the sum should be stored here. Okay, now let us run it and visualize all the operations. Okay, so look at here. I'll rerun it. I'll just stop, and since could need able to observe by starting stage, highlight the execution and then run it once. Okay, so now 0 plus 1, 1 is there, 1 has come back, 1 plus 1, so it's 2, it's been incremented to 2, 1 plus 2 is 3, now 3 is coming and 3 will be fed back here. Okay, so 3 plus 2, 6, 6 5, 5 plus 4, 6 plus 5, then 15 plus 6 is 21, then 21 plus 7, 28, 28 is coming here. Similarly 36, 36 plus 9, 45, and 45 plus 10, it is 55. It is reached the n count, and automatically VI has stopped the execution, and you can observe the sum of n integers as 55. So this is how the sum of n numbers of sum of first n numbers can be found. And look at the one important concept of the LabVIEW here. Okay, so I have used a double precision value here, which shows in orange color, but the loop terminal, n count terminal, was in integer. That's why there is a red dot you can observe at the n terminal. Similarly, at the output you can observe the red dot. That is named as coercion dot in the LabVIEW. So that will happen, or that will occur whenever the mismatched in the data type is being present. Okay, so that mismatch in the data type can be rectified in many a way. You can call the controller by the LabVIEW block diagram, so that it will automatically adjust the data type that it wants. Okay, otherwise you can change the representation of your fed data type so that that red dot will disappear. Okay, this will happen whenever, suppose if you give the larger number, then truncation of the output need to be happen. At that time you may have a malfunction result if you do not match the data type, if you are ignore that red dot. Okay, that should not happen. As a core concept of the LabVIEW, okay, you need to understand the fundamental core concept of the LabVIEW, so which help in getting the professional path certification by the LabVIEW 2. Okay, so here also you can use the red dot. So one option I have changed myself with the control to the representation. What best you can do is you can delete the sum of n numbers output, say Control B for removing the broken arrows. I'll right click here and I'll create indicator, so which will automatically create the indicator of its own data type. Okay, so this is the beauty of the LabVIEW tool. Okay, so now I'll call this sum of n integers. You can also do like this. So now run it again and see the output, how it has been arrived. Okay, so if the delay is more, you can give the lesser delay and you can observe each path. If you could not able to observe each iteration, you can increase the delay and you can calmly execute each and every step, so that you can understand the concept of the experiment. Okay, so I'll quickly, what is this icon we have used here? It's a shift register. This is the only thing need to be understood for understanding the experiment easily. Okay, shift register were used to pass the iterated result to further add and to store the final result. So this is how your sum of n numbers will work out. Thank you.